Welcome to our 11th video in the Python for Artificial Intelligence and Machine Learning series. My name is Dheerajchoudhary, and today we are exploring loop control statements where we will see break, continue, and pass. These control mechanisms give you fine-grained control over loop execution, allowing you to create more efficient and flexible algorithms. We briefly touch on break and continue in our previous videos, but now we will explore them in depth along with the pass statement that we have not yet explored. So these tools are essential for implementing complex algorithms and handling edge cases in artificial intelligence and machine learning code that we would be looking in our upcoming series. So let's understand what is loop control. We have already seen this, but let's uh, go through it again. So loop control statement gives you more precise control over how loops execute, while standard loop process every iteration based on their sequence or condition. The control statements lets you modify this behavior in three primary ways: breaking out of loop entirely, second is skipping particular iterations, and third is creating placeholders code with the pass statement. So many a times you want to define a function, but you don't want to write a code inside it. So in that case, you can use a placeholder pass statement. These mechanisms provide critical benefits for algorithm development. They allow you to handle special cases without complex nesting, optimize performance by avoiding unnecessary work, and implement sophisticated control flows required by machine learning algorithms. So let's understand how a simple and control loop look. What is the difference between simple and control? So we have already seen this before, but right now we are just going to go through it to understand. Just a refresher you can consider. So here we are on our coding platform. So I will just go ahead and open this. So this is our normal loop. So in this, I have used a for loop where I am saying that it is going to print a range of numbers starting with 0 and it will end at 9. So it is going to print 10 numbers from 0 to 9. So range 10 says that 10 minus 1. So it will iterate for 10 times. So when I go ahead and run this, so you can see that it has printed from 0 to 9. So this is our normal loop where we defined a condition and it ended the loop after completing that condition that we have provided as part of the loop. Now, what is control loop? I'm using the same code, but this time what I'm saying, after printing till 5, I don't want further numbers to be printed. So for doing this, what I am doing is I am going and saying that if I is greater than 5, break. That means the loop existing behavior is being modified and it is going to go ahead and break. And this is how control statement works, where it is breaking your existing loop. So this is the main condition of loop, and by using break, we have modified it. Now let's go back and see what we have. So now we are going to talk about the break statement. So the break statement immediately terminate the loop it's currently in, regardless of the loop's normal termination condition, as we just saw. When Python encounters a break, it exits the loop and continues execution with the code after the loop block. So this is particularly useful in several scenarios. Suppose when you find what you're looking for and don't need to check the remaining items, that time you can use the break statement. When further processing becomes unnecessary once you have achieved your task that you were looking for, and when you encounter an exceptional situation like you get some error or something, in that case also you can use a break. You can also so from machine learning perspective, how we use it: so when implementing early stopping in machine learning training loops, or when we need to exit an infinite loop. So the break statement also commonly used in machine learning algorithms to implement early stopping when a model converges or validation matrices indicate potential overfitting. So these are a big jargons that we would be covering in our upcoming videos. So now let's understand this, how break statement works with 5 different examples. So I will jump back to our screen, and here is the 5 example that we are going to talk about. So let's talk about our first example. So in this example, we are looping through the list of numbers to find the odd number. So over you see, this is the list of numbers starting from 2 ending with 10. Okay. As soon as we detect as soon as we detect the first odd number, we print and immediately exit the loop using the break statement, as you can see over here. If num%2 is not equal to 0, I will go ahead and say first odd number found and print that odd number, and it will immediately go ahead and exit the loop. So because of this break, instead of going through all the elements, it is only going to go ahead and stop at the first odd number. So if I go ahead and run this, you can see first odd number found. So it iterated till 9th element, then break was applied and it came out and the loop was terminated. Now let's see another example where break statement can be used. So in this code, we are searching for a specific name, that is Dheeraj. So right now my name is at the end, so it is going to iterate the entire list. But instead of this, if I would have, I just I want to avoid unnecessary processing of other elements, what I will do, I will just go ahead and define it here. So in this case, what it is going to do is it is going to go ahead and terminate the loop once my name has been found. So if I go ahead and run, you can see first it checked the first element. The first name was Alice, second name was Dheeraj. As soon as it got my name, target found, and it stopped further checks. So that is the second use case where you can use break statement. So now in the third one, here we are processing a list of data values. But wait, one of them is none, as you can see, the third one, which is invalid. So as soon as we hit this bad data that we are trying to portray over here, we print an error and exit the loop using the break statement. So in real world use of a break, this kind of unexpected exceptional conditions, we use this kind of we use break statement in this kind of scenarios. So if I go ahead and run this, you saw that it processed the 2, and when it got the bad data, automatically it exited the loop. Now in the fourth example, it is a bit aligned towards how machine learning works and how you can use break statement over there. So usually in machine learning training, we often stop early if the model reaches a certain performance or condition. So this code that I have written, it simulates that. So training runs for 10 epochs, but at epoch 5, we trigger early stopping and exit the loop with a break. So this is just a example to show you how you can use break for performance optimization. So while you are going ahead and running a training model, so every epoch it is going ahead and checking if any certain value of performance is met, or if there is any overfitting. In that case, it will go ahead and stop instead of going in an infinite loop. That is another use case of using break to exit the loop. Now I am going to show you an infinite loop. That is the first example. This is a classic one that keeps asking user for input till the time the user types exit. So the break lets us exit the loop safely over here. So this is commonly used in interactive programs, games, or some command line tools that we use. So first, in the user input, we are saying type exit to quit, and the loop starts. So when I go ahead and run this, automatically see it is asking me type exit. Instead of exit, I am going to say go on or go. The loop is still running. It is an infinite loop. Till the time I am not going to give the right value, now I give the value true, it is still running. So to exit an infinite loop, what I am going to do is I am going to go ahead and say exit, and as soon as I used exit, the loop was ended. So this is the fifth example by where you can understand how break statement can be used to exit and loop. Now let's go ahead and see nested loops for break statement. So an important detail to understand about break statement is that it only exits the innermost loop it's contained in. This can be source of confusion when working with nested loop. If you need to exit multiple levels of loop, you have to use several other options. One approach is to use a flag variable that you can set when you want to exit, then check this flag in each loop level. Another approach is refactor your nested loops into a function and use a return statement which will exit both the function and all the loop it contains. In machine learning, nested loops are common. So in our example, I am going to show you what is the difference in this nested loops, how you can break in different ways. So the first example over here, what we have is I have defined the break statement in the innermost loop. That means right now we have two for statements. This is loop 1, that is outermost loop, and this is loop 2, that is innermost loop. Now my break statement is in innermost loop. So what I'm trying to say is when my condition is met, the break statement is going to bring me out of the innermost loop to the outermost loop. It is not going to exit the entire program. That is how break statement work. So if I go ahead and run it, let's try to understand it with the output. So as soon as it started, so the first from the range till 3, that means it will go from 0 to 2. So it started with the value of I. So I is equal to 0. So once I is equal to 0, it came at an innermost loop, and after coming to innermost loop, it iterated over here to see if I is equal to 1 and j is equal to 1. Then same, I is equal to 1 and j is equal to 1. I is equal to, so over here I was 0 both the time and j became 1 and 2. This is the innermost loop which is going on. Once uh, the entire loop was executed, it came back to the outermost loop where the value of I changed from 0 to 1. As soon as the value of I changed from 0 to 1, it ran for the first time where I is equal to 0. The condition was not met. But after that, when it ran for other times, it went ahead and the loop was exited. And when the loop was exited, it is giving a statement saying that breaking at I and j, that is I is equal to 1 and j is equal to 1. And as soon as it broke, it is showing us that it brought us to the outer loop, and again the outer loop start the execution where the I value changed to 2 and it came inside. It iterated for 3 times because the value didn't met. It iterated all the times and it came out in the outermost loop again. So the conclusion with this example is, break statement is only going to break the loop inside which it is. It is not going to break the entire program loops if you have multiple nested loops. Now let's understand second use case over here. When you want, when you are in a nested loop and you want all the entire program to be terminated, that is the entire loop to be terminated, in that case you can use a flag. So over here I have defined the flag. So since break only exists in the inner loop, we can use flag to track when the condition is met. So over here the condition is I into j is equal to 6. So till the time this is not met, it is going to run. As soon as this condition is met, so we are modifying our variable found, that is the flag that we have defined, from false to true. As soon as it become true, what happens? As soon as this condition is met, this for loop, that is the innermost loop, is exited. It comes out. As soon as it comes out, we are checking if found, means if found is equal to true, then we will break the outermost loop also. So in this scenario, you can see that you have exited the entire nested loop. So that is how you can handle. Now let's talk about the continue statement. So the continue statement provides a way to skip the current iteration of loop and proceed directly to the next iteration. So when Python encounters a continue, it jumps back to top of the loop, which reevaluates the loop condition and starts the next iteration if the condition is still true. Any code in the loop that comes after the continue statement is skipped for that iteration. This is particularly useful when current item requires no further processing, when handling special use cases, when implementing filter like behavior, or when you want to avoid deeply nested conditional blocks. In machine learning applications, continue statements are often used during data pre-processing to skip invalid or outliers data points that we come through, or during training to skip iterations that meet certain criteria without terminating the entire training process. So if we go ahead and try to understand this by example, so the first example that we have over here is, we are only going to process positive numbers. So in this code, we are going to loop through the list of numbers that you can see, which starts with 5 and ends with -6, and summing only the positive values. So in sum, so we are going to sum only the positive values. So the continue statement is used to skip over non-positive numbers. So whenever there is a positive number, then only we are going to sum them. If there is a negative number, we are going to leave them. So if you go ahead and see this loop, so the loop starts for num is numbers. So it will first pick 5. It will go ahead and see over here. If this is less than equal to 0, then continue. But then continue. So if the number is not negative, so if the number is negative, it is in minus. That's why we have used 0. If the number is greater than 0, then it will go ahead and continue. Okay, and it will say sum positive is equal to the current sum, that is 0 plus the number, and the value of sum positive will be saved. So first time it will become 5. So see, added 5, sum is now 5. Second time added 8, sum is now 13. So it went to 5, then it went to -2 as it was not greater than 0. It was skipped. Then it went to 8, it was greater than 0. We went ahead and uh, added that. Then again it is a positive number because it is equal to 0. It was again added, but the sum was the same. Then it jumped to 10, then 3, and then it ended with the total of all the positive numbers. So that is how you can use continue. So over here we are skipping the non-positive numbers. So if there is a non-positive numbers, we are not going to add them. If we have a positive number, then and only then we are going ahead and adding them. Okay, so let's understand what is our next example. So in our next example, it shows how you can continue, how continue can help when dealing with incomplete records. So we have a list of dictionary representing people, but one of them is missing a score. So over here you will see the first one, Alice, is having a score of 85. Third one is having a score of 92, but Bob is missing the score. So how we are going to use continue in this kinds of use cases? So if score is not in the item, we skip such entries with a friendly message. This ensure we only process valid data. So what's happening in the code? So as soon as the loop starts, we go ahead and see if score is not present in the item, we go ahead and inform that the data is incomplete. That means we are not going to process it. So we are giving a friendly message informing that. So when I go ahead and run this, so it will go, so first it is going to go ahead and it is going to execute this dictionary, then second, then third as part of this list. So when I go ahead and run this, you can see first it processed Alice, score is equal to score is 85. Second, it said that we are skipping Bob because the data is incomplete, and third, it processed the data because it was complete. So this is second behavior by which you can understand how continue can be used. So now let's talk about some continue statement. Means some use cases, real-time use cases of continue. So it's a versatile and it appears in several common patterns across Python programming. So first pattern is in data filtering, it allows you to skip elements that don't meet your criteria without breaking the loop entirely. The last example that we saw. For error handling, it continue lets you skip problematic data points while processing the rest of your data set. It's also useful for performance optimization by avoiding unnecessary processing steps for certain items. In data preprocessing, one of the most common tasks in machine learning, continue helps handle missing or invalid values gracefully. When dealing with complex condition, continue can simplify nested logic by providing early exits for special cases. So in iterative algorithms, it allows selective processing of element based on dynamic criteria. So let me go ahead and talk about the use cases that we have over there. So what is our first use case? The first use case is data filtering. Let's see, understand that with an example. So as part of this code, what we are doing, so we start with a list of numbers that starts from 1 and ends with 20. So the for loop goes through each number one by one, that is element by element. First it will take 1, then 4, then 7, then 10. So inside the loop, we check if num%0 is not equal to 0, that is even number or not. Okay, meaning if the number is not divisible by 2, that is if it's odd. So if the number is odd, what happens? We continue to skip it if the number is odd, and if the number is even, it will go down and reach the print line and it will get displayed that it will display the even number. So this helps us to filter the list directly inside the loop itself. That is how you can use continue statement as part of data filtering use case. So if I go ahead and run it, as I said, for loops gets initiated, it checks if it is an odd number or not. Yes, 1 is an odd number, that's why it is not printed. Okay, so it comes over here, as it is odd, it will skip the odd number. Okay, and it, so as soon as it comes here, continue, it will bring back to the for loop again and it will go for the next one. Okay, now if it does not, then only it is going to go, if it is an even number, it will go ahead and print it. So that's how it has printed 4, 10 and 20, because those are the even number. Now we will talk about our second use case, that is error handling. So in error handling, what we are doing is we are looping through a list of string values that you see over here. Even though it is, I have written 142, but if you see it carefully, everything over here is in double quotes. That means it signifies that the list of values inside all are string values. So before converting, we check if not if it is a digit or not. So what we are going to do is over here is we are going to skip invalid data, that is non-digit strings, is part of error handling. So before converting, we check if it is a digit. This ensured we are only working with clean numbers. If it's not a digit, it continues to skip that iteration completely, and valid strings are converted into integer value and then printed. So as soon as we start the loop, first we will go with 100. Then if it sees that whether the value is a digit. If it is it's not a digit. If the value is not a digit, we are going to go ahead and get a message. So if I go ahead and run it, so as you can see, 100 is a digit. That's why we didn't got any message from here. That means this condition was not met. Okay, so we went ahead and printed this, that is converted to 100. So we have converted that value to 100. Now if we go to ABC, it's not a val dot is digit, it's true, and we went ahead and said skipping invalid value ABC. Same happened for 42, it is valid, that's why we printed converted. And nan is again not valid, that's why we said skipping invalid values. So that was the another use case for error handling. Now we will see the third use case, that is for performance optimization. So in this, we have a list of numbers and we only want to process the smaller ones. So inside the loop, if n is greater than 100, checks if the number is too large. If so, we skip it and continue. This way, numbers greater than 100 are ignored. Only the smaller numbers reach the print line over here, saving the time and keeping our loop focused towards the small number instead of high numbers. So over here, whatever you see is above 100, we have not processed it. So 200, 300 is not processed. Apart from that, all the data is processed. That is how you can skip the unwanted records and only process the one that you're looking for your performance optimization, for targeted processing. Now, the fourth example. So in this, we are processing a list of people represented by dictionaries. So over here, these are the list of people and everyone is represented by a dictionary that is a key value pair. So each dictionary might or might not have a name, as you can see over here. So we use person.getName. So when we use person.getName to safely grab the name, it gives us an empty string. If the key is missing for us, then we check if not name. If it's missing or empty, we skip that entry with continue. So only the valid names that you see over here as part of this key pair, we are going to go through it and get that printed. So if I run this, so first it went over here, name is equal to dot get name. So if not name, so first we got the name. Okay, so when we searched for a value and we got a value in return, then we executed the print statement. But over here the name is blank, that's why it didn't got executed. Again for the third one, name was there, it got executed. That is a print statement and it gave the valid name. So that is how you can use this in the use case of data pre-processing. Now let's go to other, that is the complex condition. So as part of this complex condition, what we are doing, we are looping through tasks, each having done status and priority. So over here, done and priority. Okay, there are two statuses that you can see over here. So instead of writing nested if statement, nested if condition, we flip the logic. If the task is not done or the priority is not high, we continue to skip it. This way, we only tasks the the only task that we are passing with the continue statement is done and high priority, which is going to go ahead and reach the print line, which keeps the loop flat and easy to read. So if I go ahead and run this, you will see that we have only processed that entry which is having the task done and priority as high. So this is the third one, because that was our only focus to look for. So that is how you can this is how you can use it in complex conditions. where you have to look for a specific key value pair. Now let's talk about the last use case, that is the iterative algorithm, that is selective processing elements. In this, what we are doing is process only every second number as part of the list that we have. So over here we have a range 10, that means it would be from 0 to 9. So it is only going to process the second number. Okay, so over here we will use enumerate to loop over the list of numbers while also tracking the indexes that we have that starts with 0. So if the index is even, in this case, uh, we skip it with continue. Only items at odd position, that is the item at position of 3, 7, this kind 9, these kinds of odd condition values will be printed. So if I go ahead and run this, so see, 1 is odd, that's why we have printed the value of 1. Then 3 is odd, we have printed the value of 3. So whatever is at the indexes, we are printing the value of it. So over here we are skipping the even indexes and we are only printing the value for the odd indexes. Now let's move ahead and talk about the pass statement, which is unique among loop control statements because it actually does nothing at all, like break and continue. So it's a null operation. When Python encounters it, execution simply continues to the next statement. So why is it useful? Let's understand that. So in Python, indented code blocks are required syntax for structures like loop, condition, function, and classes. So the pass statement serves as a placeholder when you need a syntactical valid block but don't want any actual code to execute inside it. So this is useful during development when you are creating a blueprint out of your program structure, when you want to explicitly indicate that you are intentionally doing nothing in certain cases, or when implementing an abstract method that will be overriding in other subclasses. So in machine learning development, you might use pass when creating skeleton code for a complex algorithm before implementing the details, or when creating abstract base classes for different model types. So let's understand this with an example. So we have three examples over here to see. So first, as we said, we can use it in functions. So when you want to define a function, but you don't right now, it is just part of your blueprint, then you can go ahead and use this. So in this way, uh, you have created a function without any code inside it. But usually, if I go ahead and just comment this and run it, it should give an error, because whenever you go ahead and create a function, you have to provide indented block with some code as part of defining the function, and that is how pass statement is going ahead and helping you with that. Now in the second one, so in this loop we check if the number is even. We are not ready to handle even numbers yet, but we just have to achieve this scenario, so we write pass there as a placeholder. So when the number is odd, we are printing it. So this keeps the structure of if else complete, so we can come back and add the even number logic later. So right now for me, I have used past over here because I don't know how I'm going to handle the even numbers. That's why I have used past. Later on, I can go ahead and remove this pass and add my logic. So in this case, in this kind of use case scenarios also, you can use pass. Now, the third one. So over here, we have defined a class called myEmpty class, but we don't add any attributes or method right now. So using pass keeps the class syntactically correct so that it does not give any error. So it lets us build the basic structure now and fill it with actual logic later, so which is great for planning or prototyping of a project that we are working upon. So this is the same like example like class as I showed you. If I am going to go ahead and comment this, it is going to give us an error because there is no code passed as part of this class definition that I am providing over here. So that is how continue. So that is how pass statement works. So let's now talk about the difference between pass, continue, and break. So understanding the differences between them is essential for controlling flow in your programs, when to use it and when not. So the pass statement that you see is essentially a no operational placeholder. So it does nothing and has no effect on loop behavior. Execution simply continues to the next statement, as we saw, including any code after the pass, but still within the loop. And on the other side, the continue statement has more substantial effect. It skips the remainder of the current iteration and jumps back to the next iteration, reevaluating the loop condition. So any condition after continue within the current iteration is not executed. The break statement has the strongest effect. So uh, it terminates the loop entirely, skipping all remaining iterations, and execution continues with the code after the loop block. We also saw that how break statement behaves in an innermost loop and in an outermost loop, how it exits those behavior also. So understanding when to use each of these control statement will help you implement the precise control flow for your algorithms that you would be working on further. Now, if I go ahead and run our last example, so over here, what I have done is I have used only one program where I am going ahead and running everything. So this is a for loop in which I have used three if conditions. Okay, if I is equal to 1, pass. We are not going to do anything. If I is equal to 2, we are going to continue. That means it is going to come to the last one. And if I is equal to 3, we are going to exit the loop. So let's go ahead and run this and see. As you saw, we have gone ahead and we have printed 0 and 1. So till the time 3 was not there, we were going ahead and checking for this condition. As soon as 3 came, we went ahead and we break was initiated, and that was the only loop in which we have defined the break. So the loop was terminated and we are out of the loop. That's why only two values were printed, 0 and 1. So that is the difference between pass, continue, and break statement. Now, last but not the least, how a loop control works in algorithm. So these are the fundamental components in many algorithms, especially in artificial intelligence and machine learning. As I have given one example again and again, I would talk about it again. Early stopping is a common technique where you break out of a training loop when certain convergence criteria are met, helping prevent overfitting. Selective training using continue allows you to skip certain examples during training based on criteria like difficulty or relevance. Input validation loops commonly use break when valid input is received, as we saw in our example where we were taking input till the time a user is not going to use exit, it is not going to go ahead and leave that loop, right? Then you can also use searching algorithms often break when a target is found. So if you are performing a search, target is found, we go ahead and terminate at that time itself, because that is what we were looking for, instead of processing the entire elements as part of this list or as part of that object that we are iterating over. Optimization algorithms like gradient descent use break when an error threshold is reached. And event handling loop uses various control statements based on event types. Data preprocessing pipeline use continue to skip invalid or missing data as part of the data set that it is processing. So these are the multiple scenarios where loop control comes into picture, and it is a fundamental component that you should be aware of. Last but not the least, let's talk about the official documentation. So as part of this official documentation that I will show you on the screen, so it provides comprehensive information about the loop control statements. The control flow section of the tutorial covers break, continue, and pass statements in detail, including their syntax, behavior, and common use case. I encourage you to explore these resources to deepen your understanding, and these are the official resources that you should go for. Okay, now, so thanks everyone for your time and participation. I encourage you to experiment with the concepts we discussed today. If you have any questions or thought, feel free to drop them in the comments below. I would love to hear from you. Remember, programming skills improves with practice, so try to apply these concepts in different contexts to solidify your understanding. Join our WhatsApp community, subscribe to our artificial intelligence and machine learning YouTube channel on which we are running this tutorial, and sign up for the Tech Insight Neuron newsletter, where very soon we are going to start the blogging series for the entire Python codes that we have covered as part of this YouTube series. So see you in the next video. Take care and bye for now.